Okay. Right, right, right. That is the question I'm given. Here we go through it, and first one. Let me do. I have given the question. I'll take my phone. Ha ha ha. Yes, this first question given. Let's tell you about this is smaller one. A machine gun fires 60 bullets per minute with a velocity of 700 meters per second. If each bullet has a mass 50 gram, find the power developed by the gun. Right. So when the bullets, that's the rate of bullets emitted given with the velocity. That means this work done converted to the kinetic energy. So we need to find that rate of this work done converted to how much the rate of the work done converted to kinetic energy. So that is the power developed by the gun. I think you can get an idea. In that way, then it is easy to understand the situation, right? Let's see then. That's 60 bullets per 1 minute, no? Yeah, 1 minute. So then the power developed by the gun is that's the work done divided by the time, right? That's work done you can find. That's work done is here. That's a kinetic energy converted, right? So you can directly the kinetic energy, that is half mv square. Okay. Then you can write that is half mv square divided by time. So you can take it like half the rate of mass change, because here mass will change, right? There's 60 bullets, one by one bullets will emitted out, right, into the square of the velocity. The mass change you can write then. There are 60 bullets for 1 minute, means 1 second is 60 divided by 60. 60 bullets per 1 minute means 1 bullets per 1 second, and 1 bullet has a mass of 50 gram, 50 into 10 to the minus 3. That's a mass. The rate of mass per 1 minute, 1 second, you can write like this, and we square of the 700 the meters per second. That is the power generated or power developed. Okay. You can simplify and get the answer there. That is 12,250 watts. Is it clear? That's the first example I'm giving you. But you can find that how many mass ejected out per 1 minute. That is 1 bullet, so it's 50 into 10 to the minus 3. That's into 60. That's 1 minute divided by 60. That means that's 1 bullet per 1 second. So it gives you 50 into that's a mass, and the kinetic energy is square of the velocity, right? Is it clear? You first need to identify what the work done here. So then you can divide it by the time it's taken. Is it clear? Can you go to the second question then? Second one, a 90 kilogram man runs up an escalator while it is not in operation in 10 seconds, right? And what is the average power developed by the man? First part they are asking that. Let's first we'll do. What's the work done here? That's he moves from ground level to higher level. So that means their potential energy will increase. So then the work done is equals to the potential energy increase. That's rate of potential energy increase. So that's means they are asking how much the rate this potential energy increase. That is the work done, rate of work done here, right? Let us this on. Question asking there's this staircase like this escalator, so it's movable one, but in this case it is stopped there, right? So the height they given, I think it's about h not given. The angle is 45 degrees, and this distance given 17 meters. The man is climbing up the 90 kilogram one, right? So the work done, this process, the work done, so it's equals to the kinetic potential energy change, mgh, right? So it's, you can write as mass is 90, is 10, and h you can find, that is h equals sin 17 sin 45. Sin 45 is h over 17, 17 sin 45. If you simplify this, you can find as 90 into 10 into 17 into sin 45. That's about 10,818.7. This much of growth. That's a work done. It's given as 10 seconds it takes to do this work. So the power equals then work done divided by the time. So 10,818.7 divided by 10 seconds. So this 1081.87, 81.9, let's say, approximation. This much of watts. This is the power now. This is the first part of the question, right? The second part of the question they are asking, the suppose next that the escalator is running, so that the escalator steps moves at a speed of 0.6 meters per second. What is then the power developed by the man as seen by the ground reference if he moves at the same speed relative to the escalator steps as he did when the escalator is not in operation, right? Now the escalator is moving 6.6 meters per second in this direction. Now the ground observer is there, and when the escalator stops, what is the velocity of the man running? I am writing this velocity of the man, that's equals to the 17 divided by 10. That's the 17 meters. He take 10 seconds to move from bottom to top. So then the 1.7 meters per second it's speed of the man, right? Now what is the speed of or velocity of man with respect to the ground, because this is the speed of man with respect to escalator, right? Now the speed of man with respect to ground, let's say this VME, so that's VME, that's equals to the VM related to the escalator I'll write it as escalator. I'm taken as a letter L here as a lift. So the VL to the with respect to the earth. And now this is already know there is a escalator relative one is VML, okay? So that's 1.7, and this escalator is most with respect to the earth is 0.6. So total together that is 2.3 meters per second. That is the speed of man with respect to the earth. And then find the time, because we know that the distance is traveled. So time taken to climb the top, that's equals to the, so 70 meters they are traveling with the velocity 2.3 now. So by dividing you can calculate the time is taken. That is 7.39. 39 seconds. Now let's take lesser time than previous. Same as previous because the same height they are moving, but it with the MGHC work done, right? It's 10,818.0, but it takes 7.39 of time. This much of what the power developed it. Is it clear? Approximately this 1460. 64 watts. Now the power is greater power than previous one. That's a higher rate of work is done with the higher rate. Is it clear or not? If you have any doubts, let me know. I'll explain again. Is it clear or not? හරිද ලියාගෙන ඉවරද? හරිද ලියන් ඉවරද? Just raise your hand if you finish writing. So I'll give you another question. So we will discuss some questions regarding the power. Right. Okay. You all finished writing? Only one is raised the hand. What about the other two? You finished writing, right? So I'll save that, right? Okay, then right, next question. The blades of a windmill, right? The blades of a windmill sweep out a circle of area capital A. The blade of a windmill sweep out a circle of area capital A. Circle of area capital A. First part of the question, right? First part of the question. If the wind flows at a velocity v, perpendicular to the circle, like this, perpendicular to circle. Then write what is the mass of air passing? What is the mass of air passing through it in time simple t? What is the mass of air passing through it in time simple t? Second part of the question, what is the kinetic energy of the air? What is the kinetic energy of the air? Right, the third part, third one, so C part, right? A, B, C, C part, right? Assume that windmill converts 25% of the wind's energy, 25% of the wind's energy into electrical energy, and electrical energy, and that capital A equals 30 square meters. Capital A equals 30 square meter, and V equals 36 kilometers per hour, and V equals 36 kilometers per hour, and the density of air is 1.2 kilogram per cubic meter. Density of air is rho equals 1.2 kilograms per cubic meter. What is the electrical power produced? What is the electrical power produced? Okay, can do it. I'll give time. Try to do this also. First you try, then I will explain. Right, the history. What I Alright, අපි බලමු. Let's see this. Right, it's given that mass, asking the mass at the time t, it's flowing through this one, right? So then the volume, this area they given as capital A, right? The volume of the air moving per second, the rate of change of the volume, that is area multiplied by the velocity. So remember we discussed this in last week, right? Any tube or cross section A, let's say the liquid come out per second, it's a velocity multiplied by the cross section area. So the wind air moving through this area, the volume is this much. You can write its mass is then A rho V, the V rho, that's per unit time, that's the rate of change of mass. Okay. Mass flowing through this area per unit time, and then at the time t, its mass flowing through it, this is A rho V into T. That is the answer for first part. You don't need to worry about that. The rate of volume flow, that is AV, multiply it by density and then multiply it by the time t, then you can find the total mass flowing through this time. And second part asking that how much the kinetic energy, and to B then kinetic energy per unit time, that is a Ke per unit time, right? Ke, that is the mass half m v square, so multiply by the time, so half mass in time t, it is A rho T, it's a mass v square and divide by time. Actually this kinetic energy means that is the power actually, right? So t cancels, so then it's a half A rho V cube, and then 25% of its efficiency given, that's value substituting. You need to know that is how much the electric power generated. So from this kinetic energy, 25%, only 25% is, let's say, electricity power generated, that is half A rho V cube, that's 25 amount of this is converted to the electricity, half, that A is given as 30 and rho is 1.2, V is given as 36 kilometers per second per hour. So it is you need to multiply it by pi over 18 to convert into the meters per second. Then is 10 meters per second, that's cube 10, and 25% of this energy. And then this 25 and first 100 is 4 there. 4 cancel this 0.3 then. 10 to 3 9 divide by that is 4.5 kilowatts. This is the electricity power generated. That's this much of energy they converted to the electricity of this much. That 25% of its efficiency they given, right? It's not a difficult one, right? Okay, then okay, write the next question. Do you have any doubts in there? I think no, right? Then write the next question. A crane. The crane means that's a heavy machinery which can lift the weight, right? The larger masses. Right? A crane lift a mass of 600 kilogram. A crane lift a mass of 600 kilogram up to 30 meters, up to 30-meter height in 2 minutes. 30-meter height in 2 minutes. What is the power of the crane? What is the power of the crane? What's the power of the crane? Right? Which is one. Let's say there's a crane like this. So that's a 600 kilogram. From here they lifted up to the, let's say, this portion. This is 30 meters. So the power equals to the work done divided by the time. Here this cable should apply the force which equals to the weight of this block. Right, then the force into the displacement divided by time. Force is 6000 Newton and 30 meters, so divided by 2 minutes, so 2 into 60. It's 1500 watts. That's the power that's machine working. Okay. Then I had an next question. I give some question, the different types of question, right? Right. A vehicle is moving with a 20 meters per second uniform velocity. The vehicle is moving with a uniform velocity of a vehicle is moving the uniform velocity of 20 meters per second. 20 meters per second on a horizontal flow of on a horizontal flow on a horizontal flow is it's enough. Horizontal flow. The flow gives us the flow is given a frictional force. The flow is given a frictional force 1500 Newton. Flow is given a frictional force of 1500 Newton. What is the power of the vehicle? is the power of the vehicle. Let's find power. Sorry. Let's see this. When this vehicle is moving with a constant velocity means that the engine should apply the traction force applied by the engine, because that's a friction is 1500. The traction should be same as the friction because of its moving the constant velocity, no acceleration, right? That's the force applied by the vehicle to maintain this velocity is 1500 Newton, because that's should equals to the 1500 when it's moving the constant velocity. So the power equals to the vehicle, that's the force applied by the vehicle multiplied by the velocity. So 1500 multiplied by 20 is 30 kilowatts. The power of the vehicle engine. So that's the way it's required. And then write the next question. I will give it. Let's see what happens when it's accelerate. Okay, then write there. A vehicle is accelerating with 2 meters per square second. The vehicle is accelerating with vehicle is accelerating with 2 meters per square second. Vehicle is accelerating with an acceleration 2 meters per square second. 2 meters per square second. On a horizontal floor. The total resistive force applied on the vehicle, total constant resistive force applied on a vehicle is 1000 Newton. Is 1000 Newton. Mass of the vehicle is 500 kilogram. Mass of the vehicle is 500 kilogram. When the velocity of the vehicle is 10 meters per second, it's 10 meters per second, find the power of the vehicle. Find the power of the vehicle. So draw the graph to show the variation of the power with the time. Draw the graph to show the variation of the power with time. Try to do this on this. let's see. That's a 1000 Newton. It's applied as a resistive force. 2 meters per square second. It's accelerating. Burn. Right. See the force applied by the vehicle is F. This is attraction. All this attractive force, right? Attraction. And the total resistive force is 1000 Newton. It's accelerating with the 2 per square. Then apply F equal m plus towards horizontal. That is the force applied by the engine minus total resistive force. The mass of the vehicle is 500 and is 2. So this is equal to then 2000 Newton. So the power was multiplied by the velocity. This power force is 2000, and this velocity, I'm asking you that it's 10 meters per square. 10 meters per second is moving now. That is total 20 watt, 20,000 watt, 20 kilowatts. Right? Is it clear now? Right. Then the vehicle, normally we know that the vehicle is moving in a an incline. Sorry, we here there's a power, the graph also we need to draw, right? The time, power. When it accelerates, the velocity increases with the time, with the constant rate. So if you also rate mean that when it's accelerating, the rate of velocity increases is with the constant rate size, because constant acceleration. So then power is also similar to this. So power depends on how the velocity change, right? So how the velocity change? Velocity is constantly increasing. So then it's same as the velocity time graph when the object is accelerating. It's clear now? Because if it is initially start with the rest, start from the rest, as v you can write that is 80 acceleration into time. So acceleration is 2, so then this is 80, then power equals F 80. If yours then A is constant, so power is proportional to the time, so it is y equals mx type. Okay, then write the next question. The mass of a vehicle is, okay, write mass of the car, motor car. Mass of a motor car is 1000 kilogram. Mass of a motor car is 1000 kilogram. Maximum power which its engine can operate, the maximum power which the which its engine can operate 50 kilowatts. Maximum power of its engine rate is 50 kilowatts. Right? Right, the first part of the question. What is the maximum velocity which the vehicle can move? What is the maximum velocity which the vehicle can move on a road? What is the maximum velocity which the vehicle can move on a road which applies 1000 Newton constant frictional force? On a road which apply 1000 Newton constant frictional force. Right? It's a friction, 1000 Newton friction. Right. This is the first part. Second part of the question, right? Then try the second question. When the vehicle is operating, or when the vehicle is moving with its maximum power, when the vehicle moves with its maximum power, if the velocity of the vehicle is 20 meters per second, if the velocity of its moving is 20 meters per second, what is the acceleration of the vehicle? What is the acceleration of the vehicle? Third part. Third one, right? If the friction applied on vehicle is 1000 Newton, if the friction applied on the vehicle is 1000 Newton, when it's moving above on an incline, and is moving above along an incline, when the vehicle is moving above along an incline, and going along incline with an angle 30 degrees horizontal. Incline with an angle at an angle 30 degrees horizontal. What is the maximum velocity which the vehicle can move? What is the maximum velocity which the vehicle can move with the same friction applied on it? When the same frictional force applied on it. Same friction applied on it. And then the fourth part. same thing. When it's moving down the incline, what is the maximum velocity which the vehicle can move? Right, the same friction is also applied. You can consider here the fourth part, right? When the vehicle moves down with the incline with the same angle, it's horizontal, and the same frictional force is applied. So what is the maximum velocity which the vehicle can move? Okay, then try. This question you can consider this. So what are the forces acting on it? When it's accelerate, how this can we solve this, right? So let's say erase this. It's working with this maximum power, so power equals to the force acting on it multiplied by, if it is moving with the constant velocity, right, that's maximum constant velocity, then the power applied by the engine equals to the friction. So then the power of the maximum power is 50 kilowatts, and then the friction you can consider that it's equals to the force given by the engine, because it's working with the maximum power and maximum velocity. Then we are going to find, so then it's 1000, and this is the maximum velocity, so it's 50 meters per second, right? Second, when it's working with this maximum power but it's accelerating, and when the velocity is 20, how much the acceleration? So when it's working with the maximum power, you got P equals Fv. You can find the power. What is the power? That's the force given by the right? So here it's okay now. And when it's working, that's the power equals, then F equals P, that's the power, maximum power it's working. Then you can find what is the force that's applied by the engine. That's a traction force applied by the engine multiplied by the velocity. In that case, that's the force. So then apply the F equal ma to find the acceleration in this time. And this power, the force applied by the engine is 1000 to 2500, and friction is the opposite is 1000. Mass is given as 1000 kilogram, and then acceleration. So it is 1500 divided by 1000 is 1.5 meters per second. That is the acceleration of the vehicle. Right. The third one, when it is moving with the moving above the incline, right? That's third one. Small object is moving there 30 degree with control. So this is a vehicle. Weight is then 1000 kilogram, 10,000 Newton, right? And then the component to the, that's parallel component to the incline, that is 10,000 sine theta, sine 30. 10,000 sine 30 is 500. The sine 30 is half, no? So I will directly write as 5,000, not 500, 5,000. Then it's moving it up. So the frictional force, that's also 1000 Newton. The same friction applied on this vehicle, and this velocity, let's say it is v. that they asking that what is the maximum velocity, right? The object is moving. So what is the force applied? Maximum force that's a force applied by the engine to moving with this velocity, or this case for maximum velocity. So the force applied by the engine should equal to total resistive force, that is the friction plus the component of the weight. So then the friction is 1000 and this is 5000. So total 6000 Newton should be applied. So then if P equals Fe, you can have. So P is the maximum power of the engine working, 50,000, and force is 600, 6000. The velocity you can write, and that gains maximum velocity is 10 to the 3, that is 25 over 3, that's 8.33 meters per second. So when it is moving in a level road, horizontal, it can move with the 50 meters per second maximum speed. But when it's moving along the incline, that's above the 30 degrees, so its maximum velocity is limited to the 8.33. That's why up in the unknown saman, it's normal general case. Practically we know that thing. අපි කන්දක් නගින්න කියොත් වාහනයක උඩරිමෙන් දාලා ගියොත් its lower velocity is achieved, because they need to do work against the weight component of its weight also. But when it's moving in the horizontal, the weight is applied downwards, so no work done by the perpendicular forces. But here this weight is against the motion, so you need to do work against it also. That's why we will less than the horizontal case. Okay, then when it's moving down, friction applied upward at 1000, and vehicle weight is mg sin 30, that's 5000 Newton. Now engine do not give any force, because they no need to give the force by the engine, because that's the downward force is greater than the friction, so it will automatically come down. So you can write them. So last case, then in this case the component of the weight is greater than the total resistive forces. Weight of component of the weight is greater than the total resistive force on the vehicle. Therefore the vehicle moves down without the engine, without the aid of the engine, force of the engine, right? So we cannot determine the velocity, maximum velocity it achieve in this case, because its velocity will increase always, because always the force is downward, it means it accelerate, so it can accelerate downward. Let's say it's in this case the friction applies 6000, so then it will not move down, right? ඒක පොඩ්ඩක් එතන එකක් දාගමු. දැන් ඒකෙම question එක දැන් වෙනස් කරලා. When the vehicle moves down, the friction applied on it is 6000 here. Otherwise, then you can write the maximum velocity. When this is 6000, right? If it is 6000, so the engine should give us the traction then. let's say it is f3 plus 5000, that should equals to the 6000 when it's moving with the constant velocity, right? So then f3 should be 1000 newton. So the power f3 into v, the maximum power it's working, then you can find that is 10 to the 3 to v. That's also work is 50 meters per second. Then it also can move 50, because of that the friction is great. If not, there are no any maximum velocity, because its velocity can increases always because of x resultant force acting on it. Here it is this height. If it is 6000, this 1000, if 5000 up to 5000, no need to apply the force by the engine. Okay, we'll do some another question and then we go on to the next part to discuss. This question also you can write this question. Right. කිසිම සද්දයක් නැහැ. තේරෙන්නේ නැද්ද නැත්තම්? තනියද? Right, I'll send the question to the WhatsApp group, right? Then you can write it. Easy way to, if I'm not reading it. That's the question you can, I send to the WhatsApp, right? Right, there's a car travels in a straight line at speed v, already given to you, right? You can try to answer. A car travels in a straight line at speed v along a horizontal road. The car moves against a resistive force capital F, is given by the equation F equals 400 plus kV square, right? The equation they given, that resistive force applied on the car you can write it because it depends on the velocity. Always that is actual thing in the vehicles, right? If vehicles are moving faster, resistive force acting on it also will be greater, right? So that's why when the vehicle is moving faster, the more fuel consuming, right? And then where F is in Newton and V is in meters per second and K is a constant. At speed V equals 15 meters per second, the resistive force F is 1100 Newton, given that one. Then calculate for this car the power necessary to maintain the of 15 meters per second, the total resistive force at speed 30 meters per second, and the power required to maintain the speed of 30 meters per second. The part B then asking determine the energy expended in traveling 1.2 kilometers at a constant speed of 15 and 30 meters per second. Last one they ask using your answer for part B. Suggest why during fuel shortage the maximum permitted speed of car may be reduced. So that is a very practical question because in these days most of the people they searching how during this petrol shortage time they try to find a way that how the energy for fuel consumption is much smaller, how you going to run your vehicle. So it is important for you to get the idea. You try, this is a very practical question, right? It is actually, then by calculating this you can get an idea why people are moving the vehicle this smaller speeds, right? So you know that these days in the vehicles are not moving much faster. So many vehicles they are moving, open all the windows and then moving slowly, right? It's been between 40 or below 40 they are moving. Okay. Given that the resistive force is equals to the 400 plus kb square, and the case of speed is 15 meters per second, right? At 15 meters per second is moving. So then you can find the, that's if they given. This means that if v equals 15, then the force is equals 1000 Newton. So then you can find the case by substituting in this equation that 1600 400 k square of 50. Value of k you can find. Right? What is then k? 1100 minus 400 divided by 15 square. Okay, this will be 3.1. No units for that. And that's having a unit, actually not a unit, they are having a unit. So you can write as newtons per square meter per Newton square seconds per square meter. This is Newton square meter per square. So you divide it by, so you can write. And then k is not the question. Power necessary to maintain this speed they are asking. So then you can find the power. Make only need per second, but you can find the power. That is maintaining this speed. That is F total force should be equals to this total resistive force applied on it and the velocity. The total resistive force in this case is 1100. This is in 15. So then you can find the power in this case. That is 16,500 watts. That means 6.5 kilowatts. B first part of A, then second part of A. The total resistive force at speed 30. So total resistance, let's say it is F2. So 400 plus, now you know the value of k, this value. So I will write it as 700 divided by square of 15, right? For the easiest of the simplification, v square is, that is 30 square. So then it is easy way to simplify this, that 30 divided by 15 square of 30 divided by 15 is 2 square is 4. This multiplied by 4, that is 700 and 2800, that is 3200 Newton. Total resistive force is now 3200. Now whatever the way you can simplify that, you put 3.111 and then multiply by 900. Also you can get this value. I'll directly use here, there's a in here, when you get this 400 to this side is 700, divide by 15 is square. This is the value of k. At the power required to maintain the speed 30, then this power required, that is the total resistive force multiplied by the velocity. So this is 3200 divided by 30. So now it is 96,000. What that means? 96 kilowatts. Right. In part B, determine the energy expended in traveling 1.2 kilometers at a constant speed of this much. 1.2 kilometers. First, we consider that how much the time is taken to move this 1.2 kilometers, right? When v equals 15 meters per second, they are asking the both cases. The first part I am considering the time taken, let's say t1, that's equals to the distance divided by the velocity. So that is 1200 meters divided by 15 meters per second. So we cancel this, and 80 second, no? So then so the energy you can calculate in this time, the energy consumed, that's power working power is 16.5 into 10 to the 3 watts multiplied by this 80. Then you can calculate that energy in joules. That is 1.32 into 10 to the 6. And in the case second, time is taken in this side is 1200 divided by 30, that is 40 seconds. It's take 40 seconds because it's moving faster, right? So but the power of its working in this case, this is the energy total. Power is 96 kilowatts multiplied by its velocity, this time is traveled 40. It will be 3.84 into 10 to the 6 joules. You can see when it is moving faster, this consumed, less time is taken, but it consumed 3.84 into 10 to the 6 joules. When it's moving the 15 meters per second, it consumed only 1.32 into 10 to the 6 joules. So then when you moving with the slower speeds, so it's consumed less energy. That means in the fuel shortage, it's better to traveling with small speeds, right? So using the answer, then you can write that the maximum permitted speed of cars may be reduced. You can write according to the answers taken in the part B. So when the vehicle is moving with the lower speeds, consume less energy, this consume less power. Right. The part C, you can write as answer, right? According to the answers, when it's moving with the 15 meters per second, that means lower speed, it consumes less energy. So for the fuel shortage, it's better to moving with the lower speed. So the speed, maximum permitted the speeds in reduced. right? Right. Then go to the next lesson, right? So keep those in mind as a power. And if they ask about calculate efficiency, then it is easy way. In this kind of question, also they can give that in, right? Let's see small parts I will add it to this question. Let's see that 1 liter of petrol or fuel. 1 liter of fuel can travel a vehicle of distances 20 kilometers. Right. So this is the petrol consumption of the vehicle they given. Okay. So what is the efficiency of the engine when it's moving the 15 meters per second and 30 meters per second? You can ask the question like this. With both the cases, the efficiency of vehicle engine, right? So 1 liter of fuel, the fuel efficiency given like this. And also they can given 1 liter of fuel burning is produce that's energy that's called the combustion energy, right? So that energy is about 4 into 10 to the 7 joules. The one fuel burning, 1 liter of fuel burning, you can consider this much of energy. You think like this, then it is easy. The 1 liter also can travel the vehicle of 20 kilometers. How you can calculate this thing? Then you can easy. You already calculated that's how much the energy consumed when it's moving with the 1.2 kilometers. Right. Similar way you can find that how much energy when it's moving the 20 kilometers. So I'll write this then. 10 to the 8 sorry 10 to the 7. Okay, let's see if the children, right? Here when it's moving the 15, so how we can get the 1 liter, let's say 20 kilometer, then let's say 20 kilometer, how much energy is consumed when it's moving, right? So with the 50 meters per second, you can find the time it's taken to move this distance, the 20 kilometer, the 20 into 10 to the 3 divided by the 15 meters per second. Time you can calculate. This is 3 and this is 4. 4 over 3. So yeah, it's a large value, no? For the easiest of the simplification, I will two kilometers. Now, then easily you can get the answer here. That's 1.2 instead of that 12 kilometers. So it's 800 seconds is taken. The previous case is 80 seconds. Now it's 10 times greater the distance traveled. So then time also increased by 10 times. So the energy in this case then, that's 1.92. I remember the answer. 10 to 6 and 10 to the 7 is will become, because 16.5 kilowatts it's working power in this 15 meters per second. So then so it's 1.32, sorry. So this is the energy they consumed in this case, and here the time is 12 into 10 to the 3 divided by 30, and now it is 400 seconds taken, and then the energy consumed is this 96,000 into 400, 3 into 400, sorry. කලින් ආන්සර් එක තමයි 10න් වැඩි වෙන එක තමයි වෙන්නේ, right? That's 3.8 into 10 to the 7. Right, now we can find the efficiency of working. The efficiency equals to this is the energy output, and energy input is given by the fuel multiplied by 100. The output is 2 to 7 multiplied by, divided by, that is the 1 liter of fuel, because I am considering 1 liter of fuel, how much the distance is traveled, and based on that how much the by the vehicle. So then 1 liter of fuel, it's given this much of energy to the engine, but it's converted this much to the output work quantity, that is 100% then. So this is the efficiency in this case, 1.32 divided by 4 multiplied by 100, that is 33%. And this case, the eta, the 3.84 into 10 to the 7 divided by 4 into 10 to the 7 multiplied by 100. In this case, that's the most of the given energy is converted to the required. This 96%. This is not practical, but according to the calculation, that's more energy given. That's this fuel consumption is 12 kilometers per hour. That's the way you need to calculate, right? that fuel. Actually this is not practical or anything, right? Because efficiency of the engine is this much, but I'm considering here that total 12 kilometers, this much of the 1 liter of fuel is consumed, right? Here also I'm considering the total 12 kilometers when it's moving the 30, but actual case is not like that, because in this case they need more energy. It's not moving like that. So I'm considering here this, when you want to calculate the efficiency, that's the way you need to do it, right? Because that's a consumption rate will be different. You know that is you have heard about that when it's moving faster, 1 liter it's cannot the same kilometers cannot move. That's the way you can calculate the there may be some other factors also affected for this when this is moving. If you close all the doors and moving, so resistive force applied on the vehicle is much greater. So then the greater resistive force means that's more energy consumed. I will erase this thing, right? It's based on the power of its engine working. Okay, we will discuss the collision. Okay, write the topic collision of particles. This also come under this listen. It's collision of particles. Collision of particles. Right. First we consider that what is a collision. A collision means it's an interaction between the two or more particles or more bodies for a short time interval. When two bodies come to each other and they collide, and then the collision time, that's in the collision, the time of two bodies are in contact very small. It's very small. So what's happened when these two bodies collision? So when they come like this, let's say, or they can be moving in the same direction and the one is come faster and then can collide also. If not, let's say the two bodies come like this and they collide and then they combine together for a short time, because that is called the time of contact time, right? It's very small. That's maybe microseconds or few microseconds, milliseconds, like that. So when they collide, they stick together, they're moving with the common velocity, and then the momentum can be transferred and then separated again and then moving like that. So that is that thing happen when two bodies moving. If the same direction, if one is moving slowly, another come fast and then collide, then we moving and then they transfer the momentum. One body transfer the momentum to the another body. The another means that's the next one. So then because of the energy transfer, or that's a momentum transfer, the moving body or the have different momentums, and then they are separated. In some cases they can attach together moving as one body, right? Different kind of collisions are there, we will discuss later. So when during the collision, how the forces acting on, initially they moving with a constant velocity, there is no force applied. During the collision, there's an impulse is applied on the equal and opposite impulse, and then force, resultant force acting on the body, it will be rapidly increases short time duration and then decreases, and after the collision they will be moving with the constant velocity. So that this is the way that the force applied on the particles during the collision is applied to the short time interval. This time will be some microsecond, let's say microsecond level. Very large force applied, that's called the impulse. Due to this impulse applied on it, they can do some work. So that's why they couple the momentum and then separated. Okay, so we'll discuss this later. Can anyone tell me? I know that you don't tell him, but you can type now. Can anyone tell me that's can two be collide without collision, without touching? Okay, two bodies collide without touching each other. Is there any collisions like that? Because you need to know what are the essentials to do collision. So that's why I'm asking. Hello. This is a yes or no question, right? It is. It can. You can write it as yes. If it cannot, like you can write it's a no. Okay, no answers. So I'll tell you. The two bodies can collide without touching, right? So as example, so have you heard about that alpha particle scattering experiment, the Rutherford experiment? There's a gold nuclei, and alpha particle will come, and when they come face to face, okay, come face like that. So this is also gold nuclei. This is also positive charge. This is also positive charge. Positive charge, positive. They having repulsive forces only. So that means when they come closer together according to the Coulomb's law, if the shorter the distance will be reducing, the force applied then is very large. So when they come closer, they never will touch to each other because of the Coulomb repulsion will be greater. So then will be returned back. Right? When they come closer, that is called the closest approach is achieved, and then return back as a collision. So it's also considered as a collision between alpha particle and the gold nuclei, but in that case the nucleus are not touched to each other because they have the higher Coulomb repulsion, right? This is one example. That's the collision without touching to each other. Okay, then write under the collision. What's the definition first? Right? Collision is the interaction collision is the interaction between two or more bodies. Collision is interaction between two or more bodies for a short time interval. For a short time interval. For a short time interval. Okay, then right, let us consider two bodies of masses m1 and m2. Let us consider two bodies of masses m1 and m2 moving along a same line. Moving along a same line. Moving along the same line with velocities u1 and u2, with velocities u1 and u2, u1 and u2, within bracket write that's u1 greater than u2, u1 greater than u2, as shown below, as shown below. Right, suppose they remain in contact for a time interval delta t, for a time interval delta t, contact contact for a time interval delta t. Right, after collision let their velocities becomes after collisions let their velocities becomes after collisions let their velocities become v1 and v2 respectively, v1 and v2 respectively. You can draw this. This is before collision, this is during the collision. I will explain this. First you draw this, I'm drawing that's how the force change with the time and the above, and this is after collision. So I mentioned you that because during the collision they in contact together and move with the common velocity, let's say, and then separated back, right? So according to this separation high speed during the collision, what happened? The two bodies will deform, their shape will change, and then again it comes to the original shape. If it can come to the full shape of its as it's shown in originally, so then called the elastic collision. If it is elastic collision, only they can come to their original shape after the collision. If not, their shape will change. So that means some energy stored inside it. So with that kinetic energy is stored as the elastic potential energy inside the body. So then it is not the elastic. So it is inelastic then. If it is elastic, means the elastic potential energy should be given to the kinetic energy completely. If some elastic energy is stored with some, that means that kinetic energy is converted to elastic energy, potential energy, and then is stored there. So those are not elastic then. So that collision is inelastic because some energy is stored there. So that's why the difference of that. That's why it's called elastic and inelastic. If not in the two rigid bodies collide, how can we say elastic? Elastic after the collision, the shape of the body will not be changed. Is normal two vehicles collide, their shape will change. If it is not there, that means if they collide, then they rebound like that, because no energy stored there as elastic potential. So that means the kinetic energy cannot be destroyed. So let's see. Right. Okay, you can draw it. The graph, how that graph will change after this point, right? I will draw it in the red color. So no force applied on it because we are moving constant velocity, means no force applied. And then during this collision, very large force is acting on. After the collision also no force acting on, and only the during collision very large force is, right? Its force repeatedly increases, and then during decreases. This force applied on the bodies during the collision only. So the time interval of the collision is delta t here. That is very small time. That's maybe microseconds. You can draw this with these figures, clearly get an idea. Then I will write. I will give you the note as what happened during this collision. This phenomena you need to know. Right, you finish drawing, then write you during the collision, except then write as a topic the during the collision. You write it as during the collision, the right during the collision, the right during collision, the interactive forces are very large. The interactive forces are very large, and the magnitude of the interactive forces are often unknown. And the magnitude of the interactive forces are often unknown. Therefore, the Newton's second law of motion, cannot be used during collision. Right. During collision, bodies in contact get deformed. During collision, the bodies in contact get deformed. The bodies in contact get deformed, and some part of their kinetic energy will store in elastic potential energy. And both the bodies have same velocity. It's during collision. Yeah. Both the bodies have same velocity. The stored elastic potential energy come back into kinetic energy, and bodies will separate after collision. Right, full stop, and then right after collision, bodies will get new velocities. Okay, then right under this, during collision, what are the things you can say? Then thus during collision, the perspective can write, the colliding bodies have same velocity. Colliding bodies have same velocity. The kinetic energy does not remain conserved. Kinetic energy does not remain constant, conserved. Kinetic energy does not remain conserved. Then last one, right, the elastic potential energy during collision equals to the elastic potential energy during collision, that's equals to the decrease in kinetic energy. decrease in kinetic energy. Kinetic energy decrease, and they convert to elastic, but they gain which convert to kinetic and then move. If it's completely not come to the kinetic energy after the collision, so that collision is not the elastic collision, right? So this one equals, you can write this as the equation if you want, because give the given data. So before the collision there has the energy half mu1 square plus half m2 is m1 u2 square. This is the energy before the collision. Subtract the energy after the collision, v1 sorry, here when the two bodies are colliding and they contact together, and right, so then m1 plus m2, the total mass of this system, and both them in the velocity v square. So this is the, that's the elastic potential in the stored during the collision only. This one you can write if you want it. If someone asks you that how much energy is stored during the collision, you can write this much, they convert to the again kinetic energy and then traveling with the different velocities. So the any kind of collisions we can apply this, momentum is conserved, but their kinetic energy are not conserved for all the types of collision. Kinetic energy conserved only for elastic collisions. We will discuss this. Okay. Then right there, right there, any type of collision, the conservation of linear momentum can be applied. Any type of collision, the conservation of linear momentum can be applied. Okay, then right under that, so during collision, the bodies exert mutual repulsive forces. The bodies exert mutual repulsive forces on each other. Collision bodies add on each other. Right, let the change in momentum of bodies are delta P1 and delta P2. Then you can draw this diagram. During collisions, bodies are moving the same velocity, and here also this one also moving the same v. And force applied on this first body by the second one, we can write it as in F. I'll write this F1 2. Here F21. This on 1 due to 2. This is on 2 due to 1. It's equal and opposite forces. It's moving. Both moving situation. This is the way that's the forces acting on this during collision. So delta P1 and delta P2 force acting on it. So you can write then that's delta P1, that's equals to the force acting on this body, because this is the impulse. Impulse is equals to the force multiplied by the time interval, time they contact to each other, right? And as a vector you can write, because this is a vector, and then delta P2 the same way you can write this is F21. These are equal in magnitudes but opposite in direction. No, that's why I'm writing in vector form, right? So according to the Newton's third law, then you can write then and reaction pairs. So then equal and opposite. So third law, you can write this F12 vector case is equal to minus F21 because of their directions are opposite. So you can multiply this by delta t minus F21 to delta t. This F12 delta t is delta p 1 minus delta p 2. So then you can take this to this side, delta p1 plus delta p2, that's equals to 0 here. That means the total change in momentum are 0. If the momentum is not changed, that means the momentum is conserved, right? After this, you can write in this side this delta p1 plus p2, the momentum, total momentum of this both the bodies. That change in total momentum is 0. If the change is 0, means the total momentum should be constant. That means there are no difference, so it's constant. P1 plus P2 is constant. So it means that for a collision you can apply the momentum conservation because the momentum will not be changed during and after the collision. To get after this, then I will give the statement for that. That's a collision. That's a momentum is not conserved for a single body, right? That both the body you consider, the system you consider, that the collision that's a momentum conserved, not only the single body, right? will then write there after that, right? Thus during collision, the linear momentum of the colliding bodies together remains constant. Colliding bodies together remains constant. Even though the forces vary in complex manner. Even though the forces vary in a complex manner. Thus we can say that momentum of the system within bracket, right, that's colliding bodies, system means colliding bodies, remains constant in each type of collisions. Remains constant in each type of collision, right? Based on this, you can categorize the collisions as the two types. So you can write there types of collision, right, as the topic, the types of collision. Okay, under that, right, the first type is elastic collision. So elastic means then there is no any kinetic energy loss during and after the collision, before and after the collision. So we can say it's elastic collision. In the other case, as inelastic collision, they are having kinetic energy loss. So during the collision, some kinetic energy stored as the elastic potential energy, it will not regain to the kinetic energy back. It will not given to the kinetic energy back, because some energy will be stored there as the elastic potential. That's the body will shape of the body will deform, right? The body will deform. So that's why they need some energy then, because of the deformation. Some energy stored there due to the formation. Okay. So then right under the elastic collision first, right there, if there is no loss of kinetic energy, of the system during collision, loss of kinetic energy of the system during collision, it is called an elastic collision. It is called an elastic collision. Then right, in this type of collision, we can say that the first one, right, in this type of collision, the momentum of the system remains conserved. Second one, right, the kinetic energy of the system before collision is equal to the kinetic energy of the system after the collision. Right, the kinetic energy of the system before collision, kinetic energy of the system before collision is equal to the kinetic energy after collision, equal to the kinetic energy after collision. So it's conserved, energy conserved means this during the collision, the forces involved in the during the collision, it is conservative forces, right? That's why the energy can conserve. You can write this because mechanical energy conservation you can apply, that means, right? So the third one, write then the forces involved during collision, forces involved during collision are conservative in nature, are conservative in nature, are conservative in nature. Okay. Then the second type, right? Inelastic collision. Inelastic collision. Okay. What do you think that I'll decide to start the physical classes for next week? Let's talk with these, because now the petrol problem is also, I think, some if you all like to come, then I will start the physical class. So I will send you the message on the group, and then you tell me that what is the difficulty you have or not. Okay, the right under the inelastic collision, the right. If there is a loss of kinetic energy, if there is a loss of kinetic energy during collision, loss of kinetic energy during collision, it is called an inelastic collision. It is called an inelastic collision. It is called an inelastic collision. Right, I will stop the class to write in this one, right? Then write in this type of collision, in this type of collision, this type of collision, the first one, right, the momentum remains conserved. You can apply, you can apply, that means the momentum remains conserved, the momentum remains conserved. And then second one, can fact, right, the kinetic energy after collision will be less than the kinetic energy before collision. That's the kinetic energy loss, that's why the kinetic energy after collision, kinetic energy after collision will be less than the kinetic energy before collision. right? This kinetic energy after collision will be less than kinetic energy before collision. And then third one, right? Because not all the forces acting on it, that's some of the forces acting on it may be non-conservative, right? Some or all the forces, right? Then you can write the third one, the some or all the forces involved during collision somehow all the forces involved during collision are non-conservative. During collision are non-conservative. Then the fourth one, right? A part of mechanical energy is converted. A part of mechanical energy is converted into heats. A part of mechanical energy is converted into heat, light, or sound. And sound, because during the collision they make sound, and also sometimes they make lights also, and most of the cases they convert to the heat. Right? These are the two types of collisions. So these are the properties of those collisions. And then another thing you need to know, that another thing we can say, if the two bodies collide and then they stick together moving as a one body, we call that collision as it is perfectly inelastic collision, right? That's perfectly inelastic. That one also we can put this time right there. The last sentence you can write there. If colliding bodies stick together, and move, as a single body after collision, then the collision is said to be single body after collision. Then the collision is said to be perfect inelastic collision. Perfectly inelastic collision, right? Perfectly inelastic means stick together and then moving as a one body. Then, right, in such collision, the momentum of the system in such collision, the momentum of the system remains conserved. But the loss of kinetic energy is maximum. Right, example for that. An example. A bullet fired into a wooden block. And remains embedded in it. A bullet fired into a wooden block and remains embedded in it. They are moving as a single body, then remains embedded in it. And also you can say that it's a clay ball you hits on the body and they stick together and moving as a single body also, right? Clay ball, it's in the clay ball or throw the clay ball on the wall also, it's stick on the body and remains, so it's also perfectly inelastic. The kinetic energy completely lost then. Okay, I'll stop the class from this point today. Next week we'll discuss in quantitatively how this collision for this, and then some questions about this. So then may this part finish, we can start the angular motion part after we are doing all the calculation related to this all. So I will do some calculations, and I intended to give some exam evaluation test for you, then it's more better for you, and you can measure how much you can evaluate yourself also, right? That's what I'm asking. So let's see the next week. Okay, then good night. And if you have any question, you can ask. If not, you can leave. And good night, Mario.